Alright, so we've talked some about header files and classes, and I added some more uh, comments into this example.cpp file so that when you download it you can see there's a little introductory spiel on OpenGL and some references to for more information about why multiple C++ files and preprocessor directives and all that good stuff. Um, so in this video, I just want to talk about the basics of OpenGL, and then I think you'll have enough to at least know which pieces to ignore and which pieces to focus on in order to do the assignment. So OpenGL, as I said, it's an API, an application programming interface for rendering 2D and 3D graphics. Works with C++ and other languages. So it's multi-language and multi-platform. The version that you get with Visual Studio has this piece. Well, you see a lot of the code for it in this GL window file, and I'm just not even going to get into that because it's a whole nother mess. But if you Google WGL, it's pronounced wiggle usually, and you might need to say like wiggle C++ or wiggle OpenGL, something like that, to get some good sites on it. But like I said, I want to skip. It's not really that important a piece right now. I mostly want to talk about a little bit about how OpenGL works, and then show you what the assignment is. So yeah, so OpenGL, and there I did a video earlier on how you set up the properties and all that stuff for an OpenGL project. So you'll need to do that. But once you've done that, then you get a whole bunch of method calls that start with the prefix GL, and there's a whole bunch of different things that you can do, and these are basically how you do set up for rendering and do your rendering. And the rendering that we're going to be looking at uses vertex buffer objects. Okay, so you can store different kinds of information in vertex buffer objects. In this project, what's stored is a bunch of positions, because we're going to put points in a bunch of different positions. You can also store colors, so you might have at each vertex of a polygon, say, you might have a different color associated with it, stuff like that. But again, in this project, we're just going to be looking at a bunch of different positions. So the way that you use a vertex buffer object, so it's again, it's a collection of information. So it's a collection of positions or a collection of colors or whatever. The way you use it is first you generate a name for it. You bind or activate the buffer, okay, and then you fill it up with data. You store data in the buffer, and then you use the buffer to render the data. Okay. The final step is destroy the buffer. I don't think in this code that they actually explicitly destroy the buffer, but sometimes it's important to do that, and it's probably good practice generally to do that. But again, this is a really simple, relatively simple program that we're looking at. So yeah, so let me go into a little more detail on what each of those steps entails. So there's this So we looked at a previous video. We saw that there's this constructor and there's this init method that gets called on the example objects in the beginning. This is this is some of that wiggle stuff that I was talking about, the WGL. Basically, it's just setting up these OpenGL procedures to make sure that procedure names to make sure that they're pointing to the right procedures. So we don't really need to worry about too much about what that is. And this is making sure that that vertex buffer objects are supported by your graphics card. Okay, so this is just a test for that. And then we have this call. So actually, you know what? Let me see. So what did I say the steps were? We got we're going to generate a name for the buffer, bind the buffer, store the data. Yeah, let's skip over a little bit to that. So there's this, there's this like basic housekeeping stuff about enabling. You can enable different capabilities. So this GL depth test, what this does is it enables ZBuffer depth sorting, and that just means that when you're rendering something, if you have a ball in front of a cube, that when it gets rendered, because the ball is in front of the cube, the ball is going to occlude or hide part of the cube, right? So just make sure that things that are in front are when they cover something in the back, that things get covered up properly, that they're arranged properly in order. And then there's this clear color is just specifying colors used to clear the buffer. So when the color buffer. So whatever color buffers we're using, when we clear them out, they're going to be replaced with all these, with this color. And this is, I don't want to go into too much detail, but just if you're curious, this is RGB-A coloring, which is basically, this amount of red, this amount of green, this amount of blue, and this amount of transparency. Okay, and 0.8, the values range from 0 to 1. Okay, so these are all 0.5s. So that's why we have a gray background in this one. Let's see. So then, I'm going to skip over this for a second. I'm going to actually, probably in the next video, I'll probably talk about this, what's going on here. But I just want to go through the GL stuff a little more. So we generate a name for the buffer. Okay, so that's this business. So and the way that works is you pass in a number and a buffer, or a pointer to a buffer. Okay, so this GL size I, this is just and GL uint for like unsigned int. Basically, you'll see when you see types like this that start with a capital GL, what that's about is that OpenGL likes to use its own types because the standard types that you find in C and C++ are not guaranteed to be the same size necessarily when you're moving to a different machine. So, and again, OpenGL is built to be, cross-language and cross-platform. So they want to make sure that when, you're declaring something as an unsigned int, that it'll be the same size no matter what language you're compiling in, or what compiler you're using, or what machine you're on, or whatever. So they have all their own types like that. But anywho, let's just go through these steps. So we said we generate a name for the buffer. So in this method, in this method call right here, this glgen buffers, what we're doing is we're saying we're going to generate one buffer, our one buffer name, and that name is going to be stored in um, vertex in m vertex buffer. So, and again, this needs to be a pointer, right? So that's what the star thing means. So our ampersand in front of the m vertex buffer is passing a pointer to this m vertex buffer value, and m vertex buffer, I think that's oh well, yeah, m vertex buffer has to be a GLU int. And I think actually it's declared in here, right? Yeah. So m vertex buffer is this GLU int here, and so that gets set up that way. So the buffer name gets set up that way. And now what happens is we can associate that buffer name with an array. Okay, so that's what this bind buffer does. It binds or basically activates this buffer that we're going to use. Okay, so and for simple renderings, you always see this GL array buffer. There's another possible thing that you could see for target here, which is so this, where we have GL enum target. So the target we have for this one is GL array buffer. Another possible one is GL element array buffer. That's for a little bit more complicated renderings usually. And then here's our buffer, right? Our m vertex buffer. Okay, so with this is basically activating it and saying, okay, now OpenGL, set up m vertex buffer so I can use it in doing my data storage and all that stuff. So here what happens is we fill up that buffer. So we're basically filling up this guy, this m vertex buffer, or the buffer with the names that's stored in here. We're binding it, so we're setting an array, right? Again, we have the same target idea. It's an array buffer. We have to give it the size of the buffer. So we have we're storing a bunch of floats here, and we have m vertices. Let's see, I think that's in here too. Yeah. So we have a vector called m vertices with a bunch of floats in it. So however many vertices there have been stored in this vector, right? Because we have vertices dot size. We're going to multiply that by float, because what we're storing in here is floats, and that'll give us the entire size of the of the data there that we have. And then we store the data in the buffer. So here's the data. Oh, here's the size of the data. Right. So that's the size of the data, and then the data starts at m vertices 0, and this ampersand says, point, because we want to point to the data, point to the 0th or the first item in the in m vertices, and usage is GL static draw. So we're going to use this for drawing this data.